Okay. The library of parent functions, this is going to be posted on eClass, so you don't actually have to copy all of these down. You can also find these on the ebook. If you look in your ebook in section 1.6, if you click the link on the ebook and go to the end of section 1.6, it will have the charts with all of the parent functions in it. All the information you need is right there. So you don't have to copy all of this down. We're going to be reading a bunch of information here at the beginning. It's going to go relatively fast, and then we're going to start using that information. So, basic parent functions. These are the basic graphs and shapes that you need to know. Up until now, everything that we've been doing has been somewhat of a review of your high school algebra classes or pre-calculus classes. Now it's going to change. It's not necessarily going to be familiar, and it's going to start going faster. So, if you get lost, you need to be in my office. Don't expect that it's going to become familiar again automatically. It won't. It just snowballs on you from this point on. You need to be in my office if you don't understand something. Okay. 1.6 contains a list of the 8 basic functions and the description of the domains, ranges, and other behaviors, whether they're even, odd, increasing, decreasing. That information is all there. We want to learn these. That means you need to memorize this list. You need to know this basic information for the rest of the semester. So the easiest way to be prepared for the rest of the semester is memorize it. Memorize what the basic shapes are and what their graphs look like. That's what you need to know. Also, any homework problems that tell you to use a graphing utility, use the one that's on top of your shoulders. Don't use any mechanical or electronic variety. Use the one that's on top of your shoulders. That is the only graphing utility you will need. It's also the only graphing utility you're going to have for the test. So make sure you can do the graphs without using a graphing calculator. If you can't do the homework without a graphing calculator, you will not be able to do the test without a graphing calculator. And how much do I take from the homework scores on WebAssign? Nothing. It's purely for your practice. So practice without a graphing calculator so you can do the test.
Where is
question.
your office?
Oh, that's a good question. Where's my office? That wall right there is a classroom. The other side of that far wall is my office. There's a hallway down there, and it's got a big brown circle wooden thing with some words on it that say mathematics and some phrase. I don't know what the phrase is. And it's just go down that. It's a door on the left. It's in that far corner right there. And if you're unsure about my office hours, they are on the syllabus. Also, tutoring in the evenings has started finally, and it's 5:30. It starts at 5:30, and I believe goes until 9:30 at night in the study room, Sunday through Thursday. Walk in there. More than likely, you will not know who the math tutor is because they're not wearing an orange shirt or a funky hat or anything. But wander around and just ask, who's the math tutor tonight? I believe that sometimes there's also chemistry tutoring and stuff happening in there, so you make sure you get the math tutor, not the chemistry tutor. You know, we share the same study room, so look for the math tutor. Usually there's 2 people working at one time. Some nights there's only 1 person working, so ask around. They will be more than willing to help you. Be so kind as to offer them the notes that I give you and post on eClass, because that'll help them figure out what you're supposed to be doing easier than just trying to look at the problem and figure out what's happening on WebAssign. It is easier if you give the tutor the notes. So make sure you pull that up or at least offer it to them. You know, I'll show you the notes what my teacher did, and they should be able to figure it out from there. Okay, so let's start talking about our functions. The first one is the easiest one. It's a linear function. Y equals mx plus b. M is defined to be the slope. And if there's no m, you have the vertical line, x equals to a number. This would be like x equals to 100 or something like that. That is the vertical line. The horizontal line would be y equals to a number, like y equals to 10. This would be a horizontal line. That's a horrible y. And then all other cases are going to be either increasing or decreasing lines. F of x equal to x is called the identity function. You don't actually have to memorize that, but you have to realize that the parent function is the function y equals to x. When we're talking about a straight line, that is the parent function we're usually talking about. The domain is minus infinity to infinity. It's defined for all real numbers. That's our lines. Our absolute value function is written using those vertical lines. F of x equals the absolute value of x. The domain is minus infinity to infinity. Notice the range starts here at 0. It includes 0, and then it's all positive values. So we write that as 0 to infinity. The x and y intercept are going to be 0, 0. Question? Yes, because it includes 0. If you're not including the point, if it had been something like this with a hole right here, then I would have gone 0 to infinity. But there's no hole there. It's a dot, so it is a bracket. And if you have infinity, you don't put a bracket. If you are getting the domains wrong on the homework that you're doing for today, it's because you put a bracket there instead of a parentheses. If you have infinity, you have to use a parentheses for infinity, plus or minus infinity. The reason for that is infinity is not a number, so you can't include it. And the bracket says it's included in the values that you can reach. Well, you can't actually reach infinity. It's not a number, so you have to put parentheses around it. It's just a notational thing. Okay, it's decreasing from minus infinity to 0. It's increasing from 0 to infinity, so you're walking downhill and then you're walking uphill from left to right. And it's an even function. It's symmetric to your y-axis. So if you fold your function along your y-axis right here, you're going to have a mirror image of itself across your y-axis. Our absolute value function. Our squaring function, f of x equals x squared. Here again, the domain is minus infinity to infinity. The range is just like the absolute value function. It's 0 to infinity. The x and y intercepts are 0, 0. Decreasing minus infinity to 0, increasing 0 to infinity. It's an even function, so it looks just like the absolute value function, except that instead of a curve, it's a straight line for the absolute value functions. So the squaring function is a little bit bowl-shaped. The absolute value function is more like a funnel in its shape. Cubic functions. F of x equal x cubed. The domain is minus infinity to infinity. The range is minus infinity to infinity. The x and y intercepts are 0 and 0. It's increasing everywhere, and this is an odd function. This is going to be similar to any odd function. An x to the 5th, an x to the 11th, an x to the 99th is going to have a similar behavior. The trick is how horizontal it looks in the middle. If I were to graph this with a larger scale, notice that this is a huge scale. It goes 0 to 100 on the y-axis, but it only goes up to 4 on the x-axis, small scale. That's why it looks horizontal. If I were to graph this on an equal scale, it would look like this. Hardly a dip in your line at all. If you were looking at x to the 99 power, it gets more and more horizontal in that interval minus 1 to 1. It would look more horizontal, and it grow faster on the outsides. But it's the same basic shape, so we only need this information. The square root function, I call it half a butterfly wing or a bird wing or something like that. It just has half of it, and it looks a little bit like a wing to me. The domain is 0 to infinity. The range is 0 to infinity, and it includes 0. You can take the square root of 0. That's equal to 0, but you cannot take the square root of a negative number, so you can't have domains that have negative values in them. And you don't get negative answers, so you don't have negative ranges. Our x and y intercept is the same, and then it's increasing everywhere. It actually is one of our slower increasing functions because it looks like it starts to level off. At some point, it just decreases how fast it increases. but it still continues to increase. And this one is no symmetry. There's no symmetry for this function. You're not reflecting it in the x or across the y or through the origin, so there's no symmetry. The reciprocal function, this is our 1 over x function. Notice that this one has domain of all reals except 0. 0 is not in the domain. You can't divide by 0. You also have 0 is not in the range. It has no x-intercept and no y-intercept. It does not cross either the x or y axis. And it's decreasing everywhere. But we have to write it without including 0 in it because it's undefined at 0. This is an odd function because it's symmetric across the origin. It's reflected from the first quadrant down into the third quadrant. Symmetric across the origin. Our step function, this one you only need to know the name of it and its basic shape because your homework is going to ask you what is, and they'll give you a graph and they'll ask you for the name of the function. This graph, just think about these as being stairs. You have a stair tread here, 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 here. It's just going up like steps. Hence it's called a step function or greatest integer function. I'm going to show you how to graph one because everybody needs to see how to graph it once. We're not going to graph it on the test and you're not going to be graphing it on the homework. So you only have to see how it is graphed. The domain is minus infinity to infinity. The range is a set of the integers, nothing else in between because it's horizontal lines. The x-intercepts is the entire interval right here from 0 to 1. It includes 0. It does not include 1. Your y-intercept is going to be the point 0, 0. And then it's constant between each of the integer values. You have a horizontal line. There again is no symmetry for this one. And you have skips. It skips everything between the integers. This one's a pain to graph, so I'll be showing you how to graph it. That is our set of 8 functions. Memorize those 8 functions. What we're going to be doing in the rest of this chapter is shifting those functions up and down, left and right, stretching them, squishing them. We need to know the basic shape, otherwise you're going to be stuck plugging in a whole bunch of numbers to figure out what the shape of that graph should be, and we don't want to have to do that. So if you memorize the basic shape, then we can be done with just 2 or 3 numbers to plug into our tables. It saves us work. Okay, so let's look at this one right here. Sketch the graph. This is a piecewise function. We have talked about how to graph the piecewise function. What this is telling you is that you use the function 2x plus 3, and you plug in values less than or equal to 1. So I would start this with plugging in a 1, and then I need another value. What kind of shape is this, by the way? This 2x plus 3, what kind of shape is that? A straight line. There's no integer power on it. There's no absolute value symbols. There's no square root on it. It's not a fraction, so it's a straight line. This one down here is also a line. So it's a straight line. I just need 2 points to graph my straight line. I have to choose the break value for both of these points. That one I have to include in both of my tables. And then I need another one for the first one, x less than or equal to 1. I need another x value. You guys did not choose an obvious easy one, which would be 0, but we'll go with -1. Information overload. Okay, so tell me about this. This first one here, does it have a line underneath the symbol, inequality symbol? Yes. So I'm going to graph it with a dot, and I'm going to put a dot next to it so I remember to do that. Let's plug in 1. We're going to have 2 times 1 plus 3. What is 2 times 1?
2.
And then you add 3? 5. So we get the 0.15. And then plug in negative 1. 2 times negative 1? Negative 2 add 3? 1. Now, let's come down here. I'm going to have a 1 and a 5. Make sure you label it. Do I graph that one with a dot or with a circle? A dot. And all the other points will be with dots for this one as well. So negative 1 and 1. And then draw your line through it. But don't continue beyond the top of here like what I did. I didn't mean to do that. It stops at that dot, and it's going to change its shape after that. Let's look at the second one, minus x plus 4. We have to plug in values bigger than 1, but we also have to plug in 1, and we are going to graph that one with a circle because it doesn't have the line under it. So that's going to be a little circle when we graph it on the graph. Now, what other value bigger than 1 do you want to plug in?
5.
Okay, 5 is actually not bad. At least you hadn't told it wasn't 100. Okay, let's plug in 1. Minus 1 plus 4 is 3. So I get 1, 3. And plug in 5. Minus 5 plus 4 is negative 1. So I have 1 and 3. Put a circle there, and then 5 and negative 1. And that's a dot. You only put a circle when you don't have the line underneath your symbol, and then everything else is dots. And there's your graph. Join them with the appropriate shape. Can we do that on our homework? About half your homework is identifying which function they're giving you in the graph. And then the rest of them is graphing. Question? You don't have to put the arrow there. I do so that when I write it, you guys can see which direction it keeps going. Because sometimes it's difficult to see my dots where it ends in my circles. So I put the arrow on the side so that it keeps going. WebAssign isn't going to have those arrows for you necessarily, so don't worry about putting them there. Yeah, you don't have to. Any other questions? Okay? You guys get to try one. Make your 2 tables. Yep, this one's a checkpoint. Does everybody have the function copied down? No one's complaining, so I'm going to move it back a screen so you can see. Notice your function, your first one is a squaring function. It's x squared plus 1. For a squaring function, you need to give me 3 values. but you also have to plug it in one, and we have to make it. And then this one was you have to plug in that one is both equations, yeah, wherever that break is, you have to plug it in there. See how I did, I plugged in one of the both equations.
That was just, that's an indication of how many, like, wearing the balance we're gonna have.
Yeah, but you have to choose the one on here because it has to be as close to it, so it'd be 0.9, 0.99, 0.99, 0.99, 0.99. So you have to figure out, well, what would it be if you actually did plug it? And then you just pick up the whole and see. Yeah, you do that. Yeah, but this one you're gonna put a dot in and it's all.
Got it.
It's getting a little too bright.
Oh, it is?
Yeah. So let's see.
Wait, what?
I think I got a square one.
Yeah.
I can get a negative on your side.
And this one too.
I went down.
On the first one, so you put in one. Oh, but you don't even have it. Yeah, it's 1, 2, it's not negative, yeah. Yeah, I was like, yeah.
It's like a yeah, because it's an open dot.
No, yeah, but it's an open circle. Yeah.
So you start as a first place.
You have 1 and negative 3.
You go down from it, so like you start here. So then so I would go down 1, and then I would go this way too. So if it's negative 1, 2, and then here that's negative 5.
Yay.
Okay, yeah, so but would I go from this point or would I go from this point? No, it's 1, 2. Oh, this one over. 5. No, but your starting point needs to be with this number. Yeah. So that needs to be your starting point. So like that's 1 and then 2. They both need to be different. Both of them like that. Yeah. Yeah. They both need to be your starting point.
It is greater than
Yeah, that one keeps going negative 1, and then the other one goes negative.
One of these points are matching that way.
Okay, so did you guys compare everything with your neighbors? Does everybody have the same graph? Does everybody have numbers on their graph?
I'm just confused because, alright, so you know how this is the starting point? So then this would be like 1, and then
that's the one.
So then you had negative 2 from.
That was not even like we're not doing that.
Right there.
Go from that to like single.
And then you have 0.
Oh, okay. I was just put them in order. Yeah, I was like, wait, how is this gonna, okay. Thank you. All right. Okay, now I gotta buy it. There you go. I was like, what the crap am I doing? All right. Now let's just. Oh, this one's not explore, so I only need 2 of these. Okay. So one.
But you don't wanna know too much.
So when the function is squared, it's almost like a font.
He listens to online conversation.
It's all the same.
And then let me know I was just in case my life is like so then just in case because honestly I don't even know.
Oh, yeah.
No, I know some.
I know you
I know
understand.
basic understanding, but she has 2 more graders.
Oh, no, that's how we always
I know. Just like, what's the rule account?
Oh, like I didn't go down. Yeah, that's wrong. So it would be 1, 2, 3, 4. Yeah, it just goes down.
I do.
And then the next one would be like 3 and then 1, 2. It would, so it would be, yeah, so it would just go straight down like this. There you go. It's only the squared ones that we have to see. Yeah. Okay. I got this.
The tourist place. Everything else is all time high. Yeah. Oh, I was there for 2 years old, studying fertility. Man, where's wearing these brains like
Okay, I understand it now. I was just having
like they won't
issues.
cancel school for much.
That was too bad for this time. I was like, what?
It's like the light will go out, the water go out.
I got this.
Like crazy. Sometimes there was like apart from the cancel school, they were like, guys, be really careful because there's too much water. Yeah.
I was lost for a little.
Is that considered trying? Like hard. I really do like I don't really have this. My father wanted to be on, my brother moved to.
Did everybody get that sketch?
Yes.
And you don't have 2 functions drawn all over the place. You just have one on one side and one on the other side, right? Yeah. Let us continue then. The greatest integer function is defined to be the greatest integer less than or equal to x. So let's look at some examples. What is the biggest integer less than or equal to minus 1? The biggest integer less than or equal to minus 1. Minus 1, because minus 1 is an integer. How about minus 1/2? Here's minus 1/2. What is the biggest integer less than or equal to minus 1/2? 0 is bigger than minus 1/2. Negative 1. How about minus 1 over 10? If I, yeah. Only in this example. How about minus 1 over 1,000? How about 0? 0 is an integer. So let's try greatest integer less than or equal to 1/2. 0. Yeah. How about 2? It's the integer itself. How about 2.1? Yeah. How about pi?
3.
Yeah, 3.14159.
I thought it was 2.7.
That would be E. Be 2. But now let's make it really hard. Negative pi.
No. 0?
Negative 4. Why? Yeah. Here's negative 3. Here's negative 4. Here's a negative pi. Yeah. When they're negative, you actually have to go to what you would feel would be a bigger integer. It has to be a bigger absolute value number with the minus sign on it. When they're positive, you go to the one that is right before it. It's kind of a twisted way of thinking. Some checkpoints for you to try. Yeah. We'll call this checkpoints 2, and then we'll make them A, B, C, D, and E. The biggest integer smaller than the fractional amount. Smaller than it is.
The biggest integers.
Okay, your computer science.
Yes.
This is a floor function.
I'm not there yet.
You're not there yet. Okay, sorry about that.
Okay.
You'll get there.
I hope so. So, the biggest integer.
Smaller than 1/2. Draw your number line. Put 1/2 on it and put the 2 integers on either side of 1/2.
I'm so stuck. I can't say, oh wait, okay. Yes, because that would be, wait, I want to understand it though. So it would be like right here, and then, yeah, so then it would have to be 0, and then 0.9 would also be in that same area, so it would have to be 0. And then 0.999, which is the same thing.
They're almost, except for the last one. Yeah.
And then the last one.
I'm still going to get it.
That would be 0. And then E would be like here. Above that.
Okay. I thought it was crazy.
That. And then it would be 2.
Is there a trick to memorizing this?
I don't like this. I don't know why. I can't practice this in my major.
You always go with left?
So what'd you guys get for answers?
0, 0, 0, 0, 2.
Yeah, all 0 except the last one. The last one is 2. Okay, so let's talk about graphing these. We noticed a pattern. So when I'm graphing this, I'm actually going to do this with very little work in hopes that you recognize the pattern. I'm going to make a table here, and we have 4 greatest integer of x, and then I'm going to look at x and y. I'm going to look at some integers, -1, something in between the integers. When I plug in -1, what's the biggest integer less than or equal to -1? -1, so that gives me a -4. Plug in -1/2. -1, that gives me a -4. Plug in 0. So 4 times 0 is 0. Plug in 1/2. Yep, 4 times 0 is 0. So we get 1/2, 0. Plug in 1. 1, 4 times 1 is 4. Get 1, 4. Plug in 1.5. 1, so that gives me 4. And plug in 2. 2 times 4 is 8. Now, watch what happens. Between -1 and -1/2, it has the same y values. So here's going to be my -1, and it has a y value of -4. And that's going to happen all the way up until we get to 0. There's a jump at 0. So I'm going to put the hole right there, and there's my horizontal line. No matter what values I plug in between -1 and 0, I am going to get a -4 for my answer. Between 0 and 1, I have a height of 0. So I put my dot. Yes. That's why we're not doing them on anything, but you're watching me do it. And between 1 and 2, it has a height of 4. And then it's going to jump. There's my step graph on it. This is very painful if you don't see the pattern to this, which is why you're not going to do it on your homework. I just did it. We are done for today. Make sure you turn in your quizzes. Make sure your names are on your quizzes.
Number 7 on the 5 homework, straight to me like crazy. Because I even sent you an email. I don't know if you got it.
I haven't gotten it yet.
I'm pretty sure I'm doing the math right.
Okay.
It's just for some reason I didn't get it right.
Okay. So I'll be looking at that sometime after 3:30 today, and I'll send you an email back. Go ahead and start.
Able to do the homework?
Yeah, you can go to past assignments at the very bottom of the homework list. It's past assignments. Click on it and get an extension again. Yeah. But let me look at it and I'll give you an email back.
So you are able to go back and do homework for your previous homework that you missed up.
Just as long as you try and do it within about a week of when it was due. Otherwise, you have to email me and I have to manually extend it.
Thank you.
You're welcome.
I know how to find zeros when it's a trinomial, but not when it's binomial.
Okay, so set 0 equal to that.
Okay.
Now, do you want to factor or do you want to add that to that side? You can do it either way.
Yeah, I was usually doing like that. 1
Equals x squared.
equals x squared.
Take the square
Then
of both
root.
sides.
Then it's plus or minus 1.
Plus or minus 1. And that's your answer. Yep. You've got it right.
Probably on the second guessing myself.
Sometimes we do that.
Yeah. I mean, one thing that I'm really trying to force myself to do this semester is just trust my gut.
Yeah.
I don't know how many times the last time I was here, I didn't trust my gut and I got it wrong. And when I realized, when I referenced it, I wasn't in the right spot.
Yeah.
So, all right.
Good question.